Hi, my friend. Welcome to Joey's Tech. First of all, I would like to thank you for all the love that you have showered on my channel. I am back with this video in which we are going to solve using dynamic programming the text justification problem. Now, while you are watching this video, you are going through a serious transformation. That means you are leveling up in your dynamic programming skills because text justification problem is one of the most complex dynamic programming problems, and I have tried my best to explain it to you in a very easy way. So I urge you to stay till the end. I urge you to keep watching this video till the end, and it is going to make sense to you, and I'm sure that you are going to move one level up in your dynamic programming skills. So let's move to the problem first. Before moving on to the problem, I urge you again to subscribe to my channel and hit the bell icon so that you don't miss out on any of my videos of dynamic programming. Now let's move to the problem. So the text justification problem is mostly witnessed in Microsoft Word. So while you are typing in Microsoft Word and you have the end margin set, and you must have noticed that the Microsoft Word automatically adjusts your line ending, and once you type the para, the entire para looks very neat and very properly arranged. The words are very much properly arranged in each and every line. So MS Word makes use of the text justification algorithm, which is what we are going to create here using dynamic programming. So it is all about putting line breaks at the correct places such that the cost is minimum, the cost of the remaining spaces I'm talking about. You are given a sequence of words in this problem, and also the limit of characters that you can put in one single line. So to solve the text justification problem, all you need is a sequence of words and the limit of characters that you can put in one single line. These two are the pillars, okay, of the text justification problem. You need to create an algorithm which places the word in each line neatly such that the arrangement looks justifiable and proper. Like I already said, Microsoft Word does that for you. So it's a clear example of using the text justification algorithm. Let's proceed. Now, in this problem, what we are going to do, we have the sequence of words. So word wrap problem solved by Joey's Tech is the sequence of words that we are going to arrange, okay, in lines, and each line has a maximum length of 15 characters. That means the number of characters that are allowed in every single line is 15. Not more than 15 we can place in one single line. So that is one of the conditions, like I already talked about, that we have, and based on this sequence of words and this maximum length per line, we will solve our text justification problem. Attention. So before I proceed further, I need you to sincerely focus on this slide. So we have an arrangement. Let's say we have got 5 words, 6 times A, 3 times B, 5 times C, double D, and 4 times C. These are just random words. Consider this as a sequence of words. That is for the sake of your understanding of the cost, and the maximum characters per line is 10. Okay, hypothetical scenario. Okay, the normal approach that you are going to follow is that you are going to stuff as many words as possible in one line. So this is going to be the example of normal approach, in which you will have the word starting with A, the word starting with B in one line, the word starting with C, and the word starting with D in the second line, and finally the final line of yours will contain the word starting with E. So this is going to be the normal approach. As you can see that you are stuffing as many words as possible in one single line. Okay. The optimized approach is going to come now, but before that we are going to calculate the cost. So the cost is going to be calculated by summing up the number of remaining spaces on each line. Let's see what is that. So 0 is the number of spaces the number of remaining spaces from line 1. 2 is going to be the number of remaining spaces from line 2, and 6 is going to be the number of remaining spaces from line 3. As you can see, the maximum length allowed on each line is 10. If you check the first line, we have the number of characters as 6 times A and 3 times B. So 6 plus 3 is 9 plus 1 space between the two words. So that is going to come out as 10. 10 minus 10 is 0. So the number of remaining spaces is 0. In the second line, it's 5 times C plus 2 times D. So 5 plus 2 is 7 with 1 space between the two words. So that makes it 8. 10 minus 8 is 2. Similarly, 6 is what we get from the third line. Now let's move to the optimized approach. So the optimized approach will have the word starting with A in line 1, the word starting with B and the word starting with C in line 2, the word starting with T and the word starting with E in line 3. This is the optimized approach that Microsoft Word is going to follow, and the text justification algorithm is also going to give you this answer when the sequence of words is this and the maximum characters per line is 10. Let's analyze the cost of this approach as well. So 4 is the number of remaining spaces that I get from line 1. 1 is the number of remaining spaces that I get from line 2, and 3 is the number of remaining spaces that I get from line 3. So as you can see from the first line itself, we have 6 times A. So 6 is the number of characters. 6 subtracted from 10, you get 4. So likewise, we have 1 and 3. But you are seeing that the total cost which is coming out in both these approaches is 8, which is the same. So how the second one is going to be an optimized approach? How we are going to discriminate between these two when the cost is same? So here the square of the number comes into picture. We are going to measure the cost by summing up the squares of the numbers. It's not a strict mandate or not a rule that you have to use the square of a number. You can make use of cube as well. But if you are going to make the use of only numbers, then the cost is going to come out as same, which is not going to solve your purpose, which is going to confuse this algorithm. So let's move to the second slide and see how the squares of the numbers solve our cost problem. So cost in terms of square, we have the same arrangement. Then here's the normal approach like we discussed in the previous slide. The cost is going to come out as 40. So 0 was the number of remaining spaces from line 1. 2 was the number of remaining spaces from line 2. So the square of 2 is 4. And 6 is the number of remaining spaces from line 3. The square of 6 is 36. The sum of the squares of these numbers is going to come out as 40. Now let's look into the cost which is calculated by following the optimized approach. So here is our optimized approach. We have the arrangement in front of us and let's look at the cost. So 4 was the number of remaining spaces from line 1. 1 was the number of remaining spaces from line 2 and 3 was the number of remaining spaces from line 3. So 4 square 16, square of 1 is 1 and square of 3 is 9. If we sum all of them up, then we get 26, and 26 is the minimum of the two approaches, the costs that have been calculated in two approaches. And based on this number 26, we can say that yes, the second one is the optimized approach, and this is what we are going to use in our solution. So now let's move to solving the problem, solving the text justification problem. So here we are at our setup. This is our cost matrix which we are going to fill with values which we are going to calculate by by thorough analysis. And there is one table here in the right. This table is just here for the calculation purposes. It is just here for the sake of your understanding, and it is going to store some intermediate calculations. This is not necessary when you are solving it at home all by yourself. You can just use your mind to make it happen, but just for the sake of your understanding, I have created this table. Okay, we are going to delete it after it is done. Let's go through the parts of this table. So we have the index over here, and we have the word in the second column. So you can see that for each of the indexes I have listed the word over here, and also I have mentioned their respective lengths in front of them. Then we have these two columns, spaces and remaining spaces, which we are going to use when we are going to calculate the values of this matrix. So you are going to witness it. So let's start from this cell. Let's start by filling this matrix. We are going to start from this cell. So as you can see, the rows of this matrix are also the words given to us, and the columns of this matrix are also the words given to us. Okay, so we are going to start from this cell. So 0, 0, that means that we have the word at index 0 in first line. That means only the word at index 0 we have to place at line 1, and let's calculate the cost of it. So how we are going to calculate the cost? As you know that it is all about remaining spaces. So what we are going to do, we are going to subtract this length from the maximum length allowed. So 4 subtracted from 15 is going to give us 11. So I'm going to put 11 over here. And since we have always discussed that we need to calculate the square of the remaining spaces, so I'm going to place 121 here, which is the square of number 11. So when we have only word in the first line, the cost is going to come out as 121. Now let's move to this cell. So 0 to 1, that means word and wrap in one single line. Now the length is going to come out as 8, and there is going to be one space between them. So 8 plus 1, 9. 9 subtracted from 15 is going to give us the remaining spaces as 6. Now the square of 6 is what we are going to place here. So 36 is the value of this cell. Now let's move to this cell. So 0 to 2, that means word to problem. Now let's sum them up. So 4 plus 4 is 8, plus 7 is 15. Now we are going to have two spaces also. So one space I am counting between word and wrap, and another space I am counting between wrap and problem. So it's going to give me the total length of characters as 17, which breaches the maximum length. So it is not allowed. So when such kind of scenario rises in this problem, during solving this problem, all we are going to do here is place infinity. So we are going to place the value as infinity over here. That means this denotes that this is not possible. This is a gone case. This is out of our hands. Maybe in a different universe it's possible, but not in ours. Okay. Now we move to this cell. From 0 to 3, that means from here to here, word wrap problem solved. Clearly you can see the combined length is going to come as 21, which breaches the maximum length. So again, we are going to fill this cell with infinity. We move to this cell now. From 0 to 4th, word wrap problem solved by. Again, the combined length is going to come out as 23, which breaches 15. So the value is going to be infinity. Similarly, the value of this cell also is going to be infinity. So we come to the next row now. we are going to start from this cell because we are talking about the word at index 1, which is wrap, which cannot be before this word at index 0, which itself is word. So we are going to start from cell 1. So 1 to 1, that means wrap. We are going to calculate the remaining spaces. To avoid confusion, I am going to omit these two values over here, and we will be calculating a new value. So let's omit this value as well. 15 minus 4 is going to come out as again as 11. So the value here will be 121, which is the square of 11. Moving on to this cell 1 to 2, that means wrap to problem. So the combined length is going to be 11 plus 1 space between wrap and problem. So it's going to be 12. 15 minus 12 is going to give you 3, and hence the value here is going to appear as 9, the square of 3. Moving on to this cell 1 to 3, as you can see, the combined value of this is going to be greater than 15. 4 plus 7 is 11, plus 6 is 17. So this case is not possible. Hence, we are going to populate infinity over here. Similarly, now in this cell from 1 to 4, as you can see, again the value is going to the sum of the lengths of these words is going to cross 15. So this combination will not be possible on one line. Hence, we are again going to place infinity over here. Similarly, in this cell also, we are going to place infinity. Moving on to the next row, we are going to start from here because now we are starting from this word, which is problem, and problem appears after word and wrap. So the values in these two cells cannot be calculated when we are starting from problem. It is obvious. So now here 2 to 2, the length is 7. Let me delete these values to avoid confusion. 15 minus 7 is 8, and hence I am going to get the value here as 64. Moving on to the next cell from 2 to 3, we are going to get the value as 13, and with one space it is going to become 14, and the remaining spaces is going to be 1. So square of 1 is 1, hence I am going to place 1 over here. Now from 2 to 4 we have to calculate. From 2 to 4, as you can see, the combined length is going to be 15, and 2 spaces, one between problem and solved and another one between solved and by. So 15 plus 2, it's going to be 17. It breaches 15, hence it cannot be calculated, and we are going to populate this cell with infinity. Moving on to the next row, which starts from index 3. The word at index 3 is solved. We will be starting from here. So 3 comma 3 is going to make it 6. To avoid confusion, I am going to delete these cells. So 15 minus 6 is going to be 9. And I will place the value 81 over here. Now 3 to 4 is going to be our next cell calculation, solved by. 6 plus 2 is 8 plus 1 space between them. So 15 minus 8 is 7. So I'm going to place 7 over here. I'm sorry, it is going to be 9. 6 plus 2 is 8 plus 1, 9. So 15 minus 9 is going to be 6, not 7. And I will place 36 over here. Now for this cell, it will be 3 to 5. So from 3 to 5, the combined length is going to come as 18 plus 2 spaces. So it's going to be 20. It breaches 15. Hence, we are going to populate this cell with infinity as well. Let me omit these cells again. Now we are going to move to row which starts with index 4. We will be starting from this cell. The word at index 4 is by. As you can see, the length is 2. 15 minus 2 is 13. 13 is the number of remaining spaces. And we will place 169, which is the square of 13 over here. Moving to this cell will cover the words from 4 to 5. From 4 to 5, that means by and joystick will be covered in this way. So 10 plus 2 is 12 plus 1 space between them. So it's going to be 13. 15 minus 13 is 2. So the value which we are going to get here will be 4. Now we will move to the final row which starts with index 5 over here. So if, as you can see, the length is 10. So when you are going to subtract 10 from 15, you are going to get the length as 5. And the value which will be populated here is the square of 5, which is 25. So this completes our cost matrix. The cost matrix is complete, but this is not the final solution. This is the information that we are going to use to calculate the final solution. That means the cost and the arrangement. Let's see how we do that. So here we are with our two arrays, one of which represents the cost. So this array over here is going to carry the cost, the minimum cost for the arrangement to be neat and precise and proper. And over here, this is our arrangement array. So this is going to store the arrangement positions for the words to be neat and proper. So we are going to use this array to place the words neatly, just like Microsoft Word does. And we are going to use this array to calculate the minimum cost. Let me place this in position. Let me put 4 and 5 over here. And here we have our cost matrix, which we are going to use. All you need to do is focus up a little, because the problem, the solution from here is going to be a little tricky. But I have tried my best to explain it to you in an easy way. So here are our 2 pointers. I'm going to place I over here. And what do these mean? You are going to understand once we move ahead. So I actually represents the row and J represents the column from this cost matrix. So we are going to start from right and move towards the left. So let's start solving. Let's start filling this cost array, in fact. So when I is 5 and J is 5, let's check the value over here. So I is 5 and J is 5, the value is 25. We are going to fill 25 as the value here. Now this is the minimum cost of a subproblem. Now the subproblem states that it only has the word joystick. Okay, forget about these words, because when we are solving a problem using dynamic programming, we have to talk about subproblems. So this is a subproblem. So what the minimum cost is going to be when we only have the word joystick with us and the maximum limit on the line is 15, it's obviously going to be 25, because 15 minus 10 is the length of joystick. So 15 minus 10 is going to be 5. Square of 5 is going to be 25. What we are going to store here is that if this word is going to be in one line, or till that position, how many words are going to be in one line and how many words are going to be in the next line, that information we are going to store here. So joystick is obviously going to be in one line. So I am going to put 6 over here. Now this means that number 5, the word at index 5 is going to be on one line, excluding the word at index 6. Now in our problem, there is no word at index 6. Okay, so that is why I have kept it as a stopper. Okay, now we move further left, so I move I to the left. Now I is 4 and j is 5. So let's see what is the value. I is 4 and j is 5. So the value over here is 4. I'm going to place 4 over here. Okay, and the value over here is going to be 6. That means now our sub problem has buy and joystick as the words. As you can see, the minimum cost is going to come as 4, which we have taken from here, and they can be placed in one line only, and that is why I have kept a 6 here. This means that 4 and 5, so the words at index 4 and 5 can be placed in one line with 6 as the stopper. So this indicates at this particular cell, it indicates that the minimum cost is going to be 4, and the index at the word at index 4 and the word at index 5, which are buy and joystick, are going to be in one line. So think it that way, visualize the sub problems, it will be easy for you, it will start making sense automatically. Now let's move I to the left. Okay, so now I have I as 3 and j as 5. So 3 and 5, as you can see, it is infinity. So when we have stumbled into infinity, that means the solution is calling for a split. Okay, what does that mean? It means that 3 to 5, that means solved by joystick, cannot be put in one line. That is why we have encountered infinity over here. So this is calling for a split. This is where the problem becomes tricky. So understand now. Okay, watch it carefully. So now the split can happen either at 5 or 4. That means either joystick can move to next line and solved by are going to remain in the first line, or buy and joystick are going to move to next line and solved is going to remain in the first line. We are going to determine that based on the cost. So when the split is at 5, that means j equal to 5. So the cost is going to be, so what is the cost at j equal to 5? It is 25. Okay, and when, so the cost of 3 to 4, because the split is at 5, so 3 to 4, that means 3 to 4, the cost is going to come out as 36. The total cost will be 61. So whenever the split is at 5, that means joystick, when joystick is moving to the next line, then the cost is going to come out as 61. Now let's calculate the cost when the split occurs at buy. This means buy and joystick are in the second line and solved is in the first line. So let's move I over here. So the value is going to come out as 4 over here, and what will be the value at 3, 3? So the value at 3, 3, that means I is 3, j is 3, the value is coming out as 81. So the total value is going to become as 85. 85 is greater than 61. So we will have to accept the splitting at 5, and the value that we are going to put here will be 61. Here we are going to put the value as 5. This means that words at index 3 and 4 are in one line, and from 5 onwards we will have to go back in the array to find whatever the word will be thereafter. Okay, j goes back to its position, which is over here. All right, and I moves for the left. I hope you have got it. If you have not got it, then comment below. I'll answer your comments. I'll answer your questions within the next 24 hours. All right, so when I is at 2, let's see what value 2 and 5 give. So 2 to 5, it's infinity. That means the solution is calling for a split. So let's split at 5. What the value at 2 and 4 is going to be, that means 2 and 4, it's going to be again infinity. That means from problem to buy, okay, we cannot put them in one line. So split at 5 is not at all possible. That means we'll have to move J one step left over here. Now let's check what the value at 2 and 4 is. So 2 and 4, it's again infinity. So this again calls for a split. So split can happen either at 4 or 3. Let's see what will be the value when the split happens at 4. So when J is going to be 4, okay, the value here is 4 plus the value from 2 to 3. So the value at 2 to 3 is 1. It is going to come out as 5. Now I'm going to move J further left. That means I am checking for the value when the split happens at 3. So when J is equal to 3, that means 61 plus what will be the value at 2 and 2? It is going to be 64. So the combined value is going to come out as 125. Now no way 125 is greater than 5. Hence we will have to settle with the split at 4. So I'm going to place 4 over here, and the value which I'm going to place over here will be 5. All right, amazing. So J goes back to its base position. I moves one cell left. Okay, so now we have 1 to 5. Let's see what is the value at 1 to 5. It's infinity, so the split is not possible because the value at 1 to 4 is also infinity. Therefore, we will move J one step left over here. Now 1 to 4, the split at 4 is also not possible because 1 to 3, the value is infinity. That means from wrap to solved, we cannot place in one line. So J moves one step left. So 1 to 3, okay, it's also infinity, but the split is possible either at J equals to 3 or J equals to 2. Okay, because we have the value of 1 to 2 calculated. That means we can put wrap and problem in one line. All right, so what happens when J split happens at J equals to 3? Okay, the value will be calculated as 61 because at J equal to 3 the value is 61. Okay, and 1 to 2 we have to check. So 1 to 2, the value is going to be 9. All right, so the sum is going to come as 70. Now we move J left to check what will be the value if the split happens at 2. Okay, so this is going to be 5 plus what is the value at 1 to 1? Oh my god, it is 121. So the value is going to be 126. Now as you can see, 126 is bigger than 70. So we will have to settle with split at J equals to 3. So I am going to put the value here as 70. The split, that means the number of words till the split are going to be 1 and 2. So I'm going to put 3 over here. I hope you are following this. If not, then put your doubts in the comment section. I'll answer them within 24 hours. J goes back to its base position and I moves one step left. Now check this out. We are at our final step now. Now 0 to 5. Now 0 to 5 cannot be possible because it's infinity. cannot be placed in one line. Okay, 0 to 4 is also not possible. 0 to 3 is also not possible because the split cannot happen, because 0 to 2 is again infinity. Only way, only cell, only position at which the split is possible is at j equals to 2. So I am going to bring j directly over here. Okay, so at j equals to 2, the split is going to be possible because 0 and 1 can be placed in one single line. So j equals to 2. Let's calculate the value. The cell value is already 5, and 0 to 1, let's see what the value is going to be. It's going to be 36. All right, so the value is going to come out as 41. The sum is going to come out as 41. Now we move j one cell left over here, so j equals to 1. Okay, we have 70 as the value, and what is the value at 0 and 0? It is 121. All right, so let me add 70 to 121. It becomes 191. Now 191 is greater than 41. 41 is minimum. That means the correct split that is going to happen at j equals to 2, and that is why we are going to put 2 here in our arrangement array, and the minimum cost that we are going to put is 41. Now 41 is our answer. That means whenever we have the following sequence of words, word wrap problem solved by joystick, and the maximum characters allowed in one line is 15, then the minimum cost is going to come out as 41. Now let's use this arrangement array to place these words in the line, and then you are going to witness whether, and you are going to see it yourself, that the arrangement is going to be very neat and proper as it is done by Microsoft Word. Okay, so from here we are going to start this. The value here is 2. This means that 0 and 1 are going to be in one line. So word and wrap are going to be in one line. So let me put them here, word and wrap. Okay, so here the pointer states that we have to move to cell 2. All right, so we are going to use a shade. We move to 2 now. Here what it is saying, value in this cell is 4. That means words at index 2 and 3 are going to be in line 2. So words at 2 and 3 are problem solved. So problem and solved are going to be in line number 2. I'm going to mark this as our path, and since these two words are going to be in line 2, hence decorate them. Let's move to 4th. All right, so here what does this state? This means that words at index 4 and 5 are going to be in 3rd line. The words at 4 and 5 are pie and joystick. So pie and joystick are going to be in the 3rd line, and this is our arrangement. This is our neat and clean and proper arrangement using the text justification algorithm created using dynamic programming. Now let's go and watch the algorithm. So this is the algorithm over here, FC. FC is our cost array. So it's going to be minimum of our matrix I, j minus 1 plus our cost array, the value at index j, where j is equal to I plus 1 in the length. The time complexity of this algorithm is going to be 0 within braces n square. So I hope you enjoyed watching this video. Remember, move one level up in algorithms through joystick. I'll see you in the next video of joystick. Thank you very much for watching this video. Ciao, ciao.